In this video I'm going to show you how to do problem number 17 from the study guide for the 5658 mini test that we're going to take. The first thing you'll want to do is understand for these types of problems normally we have two categories of or two things that we're doing in this problem. The first thing we normally need to do for problems like these is to find K, and then the other part is to solve. We can just say solve it. Well, finding K is normally what we need to be able to solve it, or the solution, finding the solution to the equation, or to the word problem I should say. Anyway, what do we know? We know that a fossilized leaf contains 20% of its normal amount of carbon-14. So under the solve it part, we know that 0.20 is equal to e to the kt, and we want to know how old the fossil is. Okay, to the nearest year. How old is the fossil? Well, we also are told that 5,600 years is the half-life. So here we don't know, in this particular part, we know that 0.20 equals e to the kt, but we don't know what k is, and we don't know how old the fossil is. So that means that we have two variables and one equation. Well, that's why we have to find the k. The half-life information is the part that we use to find the k. We know that 1/2, or I should probably back up a little bit here. I'm just assuming that we all know this part. N equals n sub 0 e to the kt. And when we divide both sides by n sub 0, the n sub 0's cancel out, and we get n over n sub 0 is equal to e to the kt. So we get this ratio of n to n sub 0. Well, when t is equal to 5,600 years, it takes that much time for n to be 1/2 of n sub 0. So if we started n sub 0 at 100, then n would be 50, but we know that this ratio is 1/2 when t has a value of 5,600 years. And so we rewrite the equation. 1/2 is equal to e to the 5,600t, 5,600k, and then when we take the ln of both sides and then divide both sides, because the ln of e, those cancel each other out, and then divide both sides by the 5,600, we get that k has a value of ln of 1/2 over 5,600. So that's our value for k, and we're going to plug that in to the a. Maybe that gets a little bit confusing, but maybe not. Hopefully not. I'm going to type this into my calculator, ln of 1/2 all over 5,600, and maybe I should do this. Maybe this would be a better thing to do. I'm going to show you what that is, and pause the video real quick and then come back. Okay, so I just typed this into my calculator, and I got negative 1.2377 blah 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 e, and then followed by e to the -4, which really means that we have negative 0.0001237, so I'll just round that. And so anyway, that's the value that all that whole decimal there, I'm not going to change anything on my calculator. I'm just going to put store, and then I'm going to store an alpha A. So I'm going to do that, store alpha A. So I have that exact value. And now we're going to replace up here in this part up here. Now we're going to replace K with that stored value that we stored in A, and we get 0.20. I guess I don't need to write the 0, do I? 0.2 is equal to e to the k again. Now that's our current a, and then we're trying to figure out, well, how long is it going to take for we're trying to find how old is the fossil. Okay, so when we take the ln of both sides, then again the ln of the e cancels each other out, and then we're going to divide both sides by k. one of my kids just came in and asked me a question, so I don't know exactly what I just said. But picking it up from where I see that I left off, ln of 0.2 is equal to k times t, and then when we divide both sides by k, and I always put a box around the k, reminding myself that I've already stored that value on my calculator, and so let's put it in green so it looks different. T is approximately equal to, and if I type in ln of 0.2 and I divide that by my alpha a, I get 13,002.797. Did it say round to the nearest year? Oh, it did. Okay, good. So we'll back up there. 13,003, which is years old. So 13,003 years old is the answer.